All right, let's talk about water. Today, we're going to go on a journey, and it starts with a question you've probably asked yourself 100 times, and it ends with the unbelievable power of a tsunami. So how are those two things even connected? Well, let's dive in.
You know the feeling, right? It rains, you see a big puddle, maybe you even splash in it, and then a couple hours later, it's just gone. Poof. But where did it actually go? That little childhood mystery? That's our starting point for understanding one of the most powerful systems on our entire planet.
The answer isn't some magic trick, but it is the start of an absolutely incredible journey. See, the very same process that makes that little puddle disappear is what drives our planet's climate and, keeps everything alive.
Okay, so here's the secret, broken down into 3 simple steps. First, you've got evaporation. The sun comes out, heats up the water in that puddle, and turns it into an invisible gas, water vapor, that rises up into the air. Then, as that vapor gets higher and cools down, you get condensation. It turns back into tiny little water droplets, and enough of those together form a cloud. And finally, when those clouds get full and heavy enough, boom, precipitation. That water falls right back down to Earth as rain, and the whole cycle starts over.
And this is where it gets totally mind-blowing. That simple little process, it's not just for puddles. It is happening all the time, on a massive, global scale. Water is constantly on the move between the oceans, the atmosphere, and the land. It's basically Earth's own giant planet-sized plumbing system.
To really get your head around this, I want you to think about our planet in a totally new way. Imagine it's just a giant sealed terrarium floating around in space.
You've probably seen one of these, right? A little world inside a glass bottle. Once you seal it up, the water inside creates its own little mini climate. It evaporates from the soil, it condenses on the glass, and then it rains back down on the plants. It's a perfect closed loop, a self-contained water cycle.
And here is the wild part. Our Earth works in the exact same way. For the most part, no new water ever shows up on our planet. The water we have right now is the same water that's been here for billions of years. It's just been recycled over and over and over again. So think about what that really means. The water you drank this morning could have been in a puddle a dinosaur stepped in. Seriously. Or look at this fact from our source material. The water being used to grow crops in a field in India today could have been flowing down the Amazon River 100 years ago. It is all the same water, just on a never-ending trip around the world.
So this whole idea of an endless cycle of water, it leads to a pretty major paradox. I mean, we live on the blue planet, right? It's covered in water. So why are we always hearing about water shortages?
It's a really good question. 3/4 of our world is covered by oceans. So how in the world can we be running out? Well, the answer isn't about the amount of water we have. It's about the type of water.
And here's the number that explains everything. A staggering 97.3% of all the water on Earth is salt water. It's great for fish, great for oceans, but for us to drink, it's pretty much useless without a whole lot of expensive processing.
This chart just puts it all into a really stark perspective. Just look at that huge chunk of blue for the oceans. Then you see that tiny little sliver left for freshwater. And get this, most of that freshwater, about 2% of the total, is locked away as ice in glaciers and ice caps. The water that's actually available for us in lakes, rivers, and underground, well, it adds up to less than 1% of all the water on the entire planet.
Okay, if that chart didn't quite land, try this. This analogy is incredibly powerful. Imagine for a second that all the fresh water on Earth could fit into just 12 spoons, okay? Out of those 12 spoons, 9 of them are frozen solid in ice caps. 2 more are deep underground as groundwater. That leaves us with just 1 spoon. And out of that spoon, half of it is in all the freshwater lakes in the world. So what's left? A single drop. 1 drop represents all the water in every single river on the planet. And that 1 drop is what so much of life relies on. So, all right, we can't drink that other 97%. But that doesn't mean the ocean is just sitting there doing nothing. Far from it. It's this incredibly dynamic, powerful system that is always in motion, and it plays a massive role in shaping our world.
All that ocean movement really boils down to 3 main categories. You've got the waves we see at the beach, the rhythmic rise and fall of the tides, and these huge underwater rivers called currents.
So first up, tides. The easiest way to think of them is like the ocean breathing in and out. Twice a day, the water level slowly rises up the shore, and twice a day, it falls back. And this incredible, predictable rhythm is all thanks to the gravitational pull of the moon and, to a lesser extent, the sun constantly tugging on our planet's ocean.
Then you have ocean currents.
Now, these are basically giant rivers flowing right through the ocean. You have warm currents, shown here in red, which typically move warm water from the equator up toward the poles. And you have cold currents, in blue, that do the opposite. Together, they act like a global conveyor belt, moving heat all around the planet, which has a huge impact on weather patterns everywhere. For instance, the warm Gulf Stream is the reason Western Europe is so much milder than places at the same latitude, like Canada.
But all this movement, it isn't always gentle or predictable. Sometimes, an event that happens deep beneath the surface can unleash the ocean's most terrifying and destructive power. And of course, we're talking about a tsunami. The word itself is Japanese, and it literally translates to harbor wave. It's a chillingly accurate name because these waves are so powerful that when they hit the coast, they can completely obliterate entire harbors.
One of the most devastating examples in recent history was the 2004 Indian Ocean tsunami. It was triggered by a massive earthquake under the sea. The wave it created traveled across the ocean at 800 kilometers per hour. That's the speed of a commercial jet. The destruction it caused was just unimaginable. In India, the country's southernmost tip was completely swallowed by the sea.
Honestly, words just don't do it justice. These pictures from the coast of Tamil Nadu in India give you just a small glimpse of the absolute power that was unleashed. Entire communities just washed away in an instant.
And what's so incredibly heartbreaking is that one of the first warning signs of a tsunami is the ocean pulling back really fast, exposing the seabed like an extreme low tide. But in 2004, a lot of people didn't know this was a warning sign. They walked out onto the exposed shore to see what they called a miracle, only to be caught when that massive wall of water rushed back in.
When you see that kind of raw, immense power, it makes one thing crystal clear. We can't control the ocean, but we absolutely have to be better stewards of that tiny fraction of fresh water that we all depend on to survive.
Because while a tsunami is a sudden, terrifying disaster, the lack of clean, fresh water is a crisis that's happening quietly every single day. These headlines aren't just hypotheticals. They represent a very real and growing challenge for people all over the globe.
So, we'll leave you with this thought to chew on. We've seen the unbelievable power of an entire ocean on the move. But maybe the greater challenge, the one that's really going to define our future, is learning to recognize the immense, life-giving value that's contained in just one single, clean drop of water.